Alright, so writing those recursive rules. How do we get from 100 to 40, from 40 to 16, 32 to 5, 64 to 25? Well, what you can start doing is dividing each term by the term in front of it and seeing if you get something that way. 40 over 100, 16 over 40, 32 divided by 5 over 16. So this is 4 over 10, or 2/5. Take out a 4, or take out an 8, and you get 2/5. And so we would expect to find 2/5 here if we multiply by 1/16 instead. And then the 32 and the 16 cross out to 2/5. So we have 2/5, which is the R because it's a geometric sequence. And so a sub 1, we need our starting point, and a sub n is going to be 2/5 times the previous term, a sub n minus 1. And there is your recursive rule. 8, 28, 48, 68, 88. And so we're adding 20 every single time. So that's our common difference is 20. And so if we add 20 every single time, start at 8, a sub n. To get to 28, we need to add 20 to 8. 48, add 20 to 28. So we're going to do whatever our previous term is plus 20. Previous term plus 20. Alright. Next one's a tricky one. So if we deal with addition, this is plus 1 plus 0 plus 2 plus 4 plus 24. Now if we deal with multiplication, times 2 times 1 times 2 times 2 times 4. If you notice that what we're multiplying by is prior to it, which is kind of weird. So to get to 2, from 2 to 4, I have to multiply 2 by the previous term 2. To multiply 4, I multiply 4 times 2 to get 8. I multiply 8 by 4 to get 32, and so it's the term times the term in front of it to get to the next one. So this times 2 is randomly out here, but that's because it's the first and second term, and so we are going to define the first and the second term. So a sub 1 is going to be 1, a sub 2 is going to be 2. So like the Fibonacci sequence, we define the first two terms here. A sub n is going to be 2 is the product of 2 times 1. 4 is 2 times 2, 8 is 4 times 2, 32 is 8 times 4. So a sub n times a sub n minus 1 times a sub n minus 2. So with Fibonacci, we were adding the two prior ones. With this one, we're multiplying the two prior ones. So that one's a little tougher, but again, look for things added, things that are multiplied, and so on. Good luck.